Welcome to today's deep dive. So, picture a massive live event, like, the Super Bowl.
Oh, yeah. Huge production.
Right. And a camera on the 50-yard line needs to send this flawless 4K feed packed with, rich HDR metadata all the way to a production truck parked miles away.
Yeah.
You can't just run a standard copper SDI cable that far. The signal would be dead before it even left the stadium.
Exactly. Completely dead. Pushing high bandwidth video over long distances is like one of the absolute hardest physical limitations in live production.
Right.
But today, we're looking at how the industry solves it. We've got a specific product page from HDTVSupply for a device with, honestly, a bit of a mouthful of a name.
It really is. It's the AJA FiDO-T-SC one-channel 3G-SDI to single-mode SC fiber transmitter.
That's the one.
Okay, let's unpack this because when you just look at it, it's this obscure half-pound metal box.
Yeah, it doesn't look like much at all.
Right, and it costs about $585.
Right.
But for anyone working behind the scenes, it's actually the ultimate problem solver for that massive physical limitation we just talked about.
It really is critical gear. Because to understand why you need it, you have to look at the physics of traditional copper wire.
Which has strict length limits.
Right. As you push high-frequency signals down a copper cable, electrical resistance and capacitance just naturally degrade the signal.
It just slowly fades out.
Exactly, until the data just drops out completely. But what's fascinating here is how this device steps around that physics problem entirely.
Oh, how so?
Well, it takes a standard 3G or HD-SDI video input and converts it into a single-mode SC fiber output.
Okay, let's clarify that single mode part for a second. That means we're talking about a highly focused laser light path, right?
Yes, exactly.
Because the beam is so narrow, the photons travel straight down the glass core without bouncing off the walls and degrading over those long distances.
Precisely. Because photons traveling through glass experience near zero resistance, that simple conversion allows the video signal to travel up to 10 kilometers.
Like 10 kilometers? That's like over 32,000 feet?
32,808 feet, yeah.
That is insane. It's like taking a short, high-pressure garden hose, the SDI cable, and adapting it to flow into a massive, frictionless cross-country pipeline.
That's actually a great analogy.
But wait, let me push back on this a bit. If it's pushing so much data over 6 miles, wouldn't a device doing that kind of heavy lifting be, too bulky to actually use in the field?
You would think so, right. But the source clarifies that it's actually this really compact, low-profile enclosure.
How small are we talking?
Just 4.6 by 1.71 inches.
Oh, wow.
Yeah, it's tiny. It's designed to squeeze into tight spaces behind equipment racks or, in crowded broadcast trucks. You can even mount it right onto a camera using a simple 5 to 20-volt DC universal power supply.
Okay, so pushing video 10 kilometers is incredibly efficient, but, and here's the catch, it creates a completely new physical challenge.
It does.
What happens when you plug connected electronics into completely different power sources across a massive venue, like a camera at one end of a golf course and a switcher miles away at the other?
Well, you run straight into the silent killer video production.
The ground loop.
The ground loop, yeah. When you connect two devices with a copper cable, but they're plugged into different power grounds with slightly different voltage potentials.
That copper cable acts as an unintended bridge.
Exactly. Current starts flowing where it shouldn't.
And that rogue current is what gives you that terrible 60 hertz hum and that visual static that just ruins a live feed.
It's a nightmare for engineers. But if we connect this to the bigger picture, converting the signal to fiber optic provides crucial electrical isolation.
Because it's light, not electricity.
Right. Because the signal is traveling as pulses of light through a glass core, it physically breaks the copper connection between the devices.
That makes total sense.
There's just no bridge for the electrons to cross. It completely eliminates ground loop problems.
So what does this all mean for you listening at home? It means the next time you enjoy a flawless, crystal clear broadcast, you're actually witnessing the invisible magic of electrical isolation, keeping the signal pristine.
It's just brilliant, highly efficient engineering. And it's worth noting from the specs that this specific unit is a simplex transmitter.
Meaning it's a one-way street.
Yep, it strictly transmits the signal out, which is all you really need at the camera source anyway.
Just a simple one-way ticket for your video feed. So to wrap up our deep dive, for $585 and backed by a 5-year AJA warranty, this tiny simplex transmitter really is the unsung hero of long-distance interference-free video.
Without a doubt.
Which leaves us with a final thought for you to mull over. As our daily screens demand higher and higher data rates, how much more of the invisible copper infrastructure hidden in our walls in our cities will eventually have to be completely replaced by pulses of light traveling through glass?